Hello, everyone. Hope you guys had a good last week. And probably all of you are looking forward to a good weekend. Or is that finished in that part of the world? I guess it's almost finished, yeah? Tomorrow is working day for you.
Yes, sir.
Okay. All right. So I don't know. This is probably going to be our last session, or maybe one more session, depending on how you guys want to go ahead with it. So I'll do a quick recap on what all things we learned about, and then probably a bit more things which probably will be, interesting for you.
So the question you asked last class.
Sorry, say it again.
So the question you asked, the question last class as our
yeah, I'm coming to that. I'll come to that quite soon. So I'm not sure if there is a new new participant in this session today. Just for the interest of everyone to get a bit of a background, if someone watches the video today as a fresh one, what all things have we covered? We have covered fundamentals of networking. Starting from how what is the relevance of networking in this world. I mean, data networking. We also spoke about extensively about how an internet connection work at home. We took an example of how modem works. We also took an example of how a Wi-Fi router works. If any of these topics you guys want to do a bit of a refresh, we can probably set up the next session as a refresh session to just give a bit of a deeper idea into how things are happening. We also spoke about something called as an OSI layer, which is probably the framework on which most of the various protocols which are used in networks are based out of. We also spoke about some devices which works on this layer. In the last session, we spoke about IP addresses. In today's session, what we are going to do is we are going to do a bit more advanced about how the different devices on network layer is going to work. There are devices like routers, and there is something called as gateway. We will talk about someone waiting from the room. Okay. So we will talk about all of that today. Yeah, so coming back to the last session, what we spoke about something called as IP addressing. What is the relevance of IP addressing, guys? Can anyone answer? I'll come back to the question that
IP addressing is to give like each device which is connected to the internet and individual like a label, a set of numerals which is differentiated by periods for labeling the devices connected, for labeling and differentiating the devices connected to the internet.
Good. Okay, so it's a collection of numbers, separated by a delimiter called dot, right? And each of those four, I gave a word because these are binary. What is the length of that that particular
3
first character? No, it's not a 3. It's 3 in decimal. But what is in binary? What is the binary equivalent of that particular? We called it as an octet. Remember?
Yes, sir.
What is the length of that?
Sir, 9, 0 to 9.
No. So the length of an octet is 8. So you can have 8 numbers in it. We discussed about, remember, I don't know if you remember, did you attend the class with Leon? Did that happen?
So not yet.
Not yet. Okay. All right. So 1, 2, 3, 4, 5, 6, 7, 8. So that's a length of that octet is 8. All right. And we also spoke about the maximum value if all of those octets are populated with a value 1, is the maximum value of that octet, which was equivalent to how much? It was equivalent to 255. Okay. So, and hence we said that the IP addresses could range from 0.0.0.0 to 255.255.255.255. So in the case of an IP addressing version 4, which is called as IPv4, it's not actually version 4, it's because of the number of decimals that we have. That's why it is called v4. Anyway, IPv4 has 255.255.255.255 as the maximum value and 0.0.0.0 as the minimum value. Okay. Do you guys remember all these things?
Yes.
Because this is important. Depending on what you learn going forward in the world of computers, you always have to come across IP addresses of servers, because you will, end of the day, you're going to be working on some communication between various computers, right? You know, be it a Java programmer or be it a Python or whatever it is, right? End of the day, all you do is to create programs or create applications which are communicating between multiple devices. So it could be an app which is developed on a phone. It could be a software which is developed for a computer, or if it's an online web page that is developed, you know, whichever stream of business that you do in the world of IT, not just networking, you got to have a basic understanding of what an IP address is all about and what is the relevance of an IP address. Obviously, as I said, the relevance of an IP address is to give an identity to a network element. Just as a, I'm just clearing this. I'll be sharing the PowerPoint towards the end today or maybe next week, so that you can go through it. But I will not be opening the PowerPoint today because there is no point doing that, because I'm going to take more of theory sessions, right? Okay, now, so we also spoke about two kinds of IP address, which are public IP address and private IP address. Remember that?
Yes.
Okay, what is a public IP address?
So a public IP address is like when it is used publicly, like in malls or in places where there are large people who's going to use the internet.
Okay, no, that's not public IP address. You might be referring to a public Wi-Fi or something. I'm talking about an IP address which is public. A public IP address is nothing but an IP address given to a device, right? A device which can be accessed publicly, right? Say for example, you have your phone, and the phone has an IP address as well, but it need not necessarily be accessible directly from say for example, Abiram is sitting in Kuwait or UAE or wherever he is. You can't directly access me because I am not publicly available. I'm not publicly accessible. So for those devices which needs to be publicly accessible, you attach a range of IP address, which is called public IP address. Okay. One of the major examples is any web servers, like say, for example, google.com, facebook.com, twitter.com. All of these are publicly accessible from different parts of the world or wherever you want to access from. So long as you have got an internet connectivity, you will be able to access these devices, right? So all of those devices which has got IP addresses which are publicly accessible are called public IP address range. And whatever those devices are, which are not publicly accessible, but you still can communicate within a closed community, is called private IP address. One of the major examples of a private IP address range is your school LAN network. Your school LAN network, unless exposed to the world, will be accessible only for the students within the school premises. Okay, so Abhiram might be there, Ritesh might be there, sitting in the school, accessing the school network. But for someone who is sitting in the public domain, in the internet, cannot access these network directly. Okay, that is called that restriction is brought in. I will tell you why those restrictions are, why that demarcation of public and private in a bit. Now, that kind of control and that kind of IP address ranging allocation is called private allocation. Okay. Now, why do we have this so confusing public range and private range? Can you sort of, we touched upon that in the last session. Do you remember why we have a public and private range of IP addresses? Anyone remembers why? Any idea why? Why do we have that categorization of public and private? Okay, so, okay, let me explain you this, right? Okay, now assume a scenario wherein I have a, so as I said, you got IP addresses, which has got 4 segments. Each of them are called octet, and I gave you a maximum value of the IP address range as 255, 255.255.255. So if you start from 0.0.0.0.0, if you take the number of IP addresses that you can have, there is a limit. The limit is, it's a big number. The limit could be in the range of 1,068,000 or whatever that number is, right? Now, there is a fixed number with which you can actually have distinct IP addresses, which means what does that mean? You can only have in this world whatever that number that I said, like, 1.6 billion or 168 million. I can't remember exactly what the number was. There was a definitive number of devices that are possible with the IPv4 IP ranging. Okay. So when the system was developed, the forum which developed the system did not really envisage or did not think in the future there is going to be more than the limit which IPv4 has. So at that point, the technology was not that advanced. We have in this world today pretty much every single device which you purchase, which is called as a smart device, be it your mobile phone, be it your laptop, be it your electric bulb, for example. You have got smart bulbs, smart fans, smart refrigerator, smart everything, right? Anything which they say smart, why do they call it as smart? Because you can access it remotely, right? Through various features. So the number of devices that requires IP addressing has increased enormously. You can't really think of the number of use cases where in which these devices can be are connected, right? Every single device that you can think of can be connected. So what does that lead to? When there is a limitation in the number of IP addresses, theoretically, what it means is that you can only have that many number of devices in the world. Okay, isn't that a problem? At one point, everyone says that, okay, hey, my IP addresses allocation is all done. You can't have any more devices. That is not possible. It's not practical, is it? Make sense? Yeah. So what they decided was they will segregate the IP addressing into two categories. A category which can be publicly accessible, a category which can be private accessible. The difference of these two categories is that you can have, say, for example, just for a practical example, there is a person called Abhiram Anoop in the public domain. And there is a person called Abhiram Anoop in the private domain. You can have actually the same name in both the cases, and you can actually connect to both the person independently, even though they have the same name. Okay, so remember we took an example of, what if there is a person, there is the same name allocated or same IP address allocated to two different devices which are connected to the internet. So assuming these two devices have got the same IP address 10.1.1.1 and 10.1.1.1, which is google.com, and someone is trying to access google.com, your network won't complete because it doesn't know where to go, correct? It could go here or it could go here. So what they did was they actually did a segregation. They did, okay, 10.10.1 in public is different from, whatever IP address that you use in private domain. Okay, I will give you a bit more example. In the private domain, say for example, you've got a modem, you got a switch or a Wi-Fi router, which has got various ports in it, assuming this is a Wi-Fi router. Okay, inside the house, you define that, whatever is connecting, whatever computer or device that is connecting to the internet has individual IP address, and this IP address starts with 10.1.1.1, 10.1.1.2. okay, so these kind of allocation happens, and it tries to access something called as a Google, which is in the internet, and 10.1.1.1 as well. This is possible. How this is possible? This is possible because this part of the network is segregated to this part of the network. So here, whatever is happening in this world has no visibility to whatever is happening in this world. Make sense? So if you duplicate the IP address also, it doesn't really matter. The obvious next question that you're going to ask is, how is this even possible? We discussed that in a bit. We will discuss that a bit more detail today.
So okay. I have a doubt.
Yep, sure.
So a private IP address can connect to a public IP address?
Yes, it can. I'll tell you why. I'll tell you how.
Okay, sir.
Okay, sorry. So assuming this is your home network. Home network is deemed as private network. Now it is trying to access something on google.com, which is another server sitting here. Okay, and this is connected to internet. All right. Now in our previous sessions, we said we've got network switch, which is on a Wi-Fi. Wi-Fi is generally represented that way, or a physical, or connected to a physical cable, either of these cases, right? And then you've got something called as modem, and then modem connects to internet through what? An ISP, internet service provider. We discussed all these things. I'm not going to go back into that. In this case, the IP address of this guy is 10.1.1.1, The IP address of this guy is also 10.1.1. So for argument's sake, right, let's not take 10.1.1 because it might confuse you. So, okay, 10.10.10.10, 10.10.10.11. Okay, these are the two IP address inside the house, and this is the guy which you are trying to access. What happens? So, as I mentioned earlier, each of these devices, each of this guy and this guy is internal, which means this is private, this is external, this is public. It doesn't matter. You can have the same range replicated on both sides, right? It doesn't really matter because they have got a demarcation here, because behind this, whatever happens, public doesn't know, right? And hence no one can reach this IP address directly. Now, someone asked me, how does this work? This work by something called as a principle called have you heard of this? Did you see that?
No, sir.
Can you see what I wrote? It's NAT. Yes, yeah. It is called Network Address Translation. Okay. That's called network address translation. What is network address translation? Okay. Okay. Let me do this. Again, coming back to the drawing board. I've got a computer here. I've got a modem. Modem is connected to who? Who is modem connecting to? We need to be very clear now. I'm not going to be asking, so I need an answer going forward, because we have explained this internet connectivity at length in various 3-4 sessions, all the sessions we used to connect. So we have got an internal computer connects to a Wi-Fi router, and then there is a modem attached to it. From the modem goes the connection to who? Where does the modem connect to?
Another computer.
No, it doesn't connect to another computer. We discussed this. What is that?
Internet service provider.
Yeah. Okay. So when you take internet connectivity at your home, what you're doing is you're connecting your modem to your whoever ISP, which is the internet service provider you are connecting to. What does the ISP connecting to? What does the ISP connect to? ISP has connected to internet, which is your public domain. Okay.
So can we call the internet as a network also, or both?
Internet is a network. Yes, absolutely. Internet is a network. The reason why we call that as internet is because all the devices in this can be accessible between each other. So you can access each of those devices.
Okay, sir.
So it could be Google, it could be Facebook, it could be any website, even if your school website, which are publicly accessible. It's in the public domain. Is what is the benefit of having this, right? Now, we have 10.1.1.10 as the IP address. You were asking how the connectivity works. So assuming you are trying to connect to Google, which has got 10.1.1.1 as the IP address. And this is a private range, and post ISP is a public range. So there has to be a conversion of the private range into public range, correct? Okay, let me show you this screen. So if you look at my computer, if you look at my this thing, look at this section, okay? You've got something called as an address. Do you see that? 203.220.165.10. Do you see that?
Yes, sir.
Yeah. So that is my public IP address. So I am at home. My computer doesn't have a public IP address, but my modem has a public IP address. Okay. Make sense?
So can you repeat?
Okay. Let me go back to the whiteboard. So you saw that IP address, right? That IP address that I have highlighted here.
Yes, sir.
That's my modem. Okay. That's my modem IP address. Now coming back to my whiteboard, I said, okay, so I also, my IP address in my home computer is 192.168.1.10. Okay. And I have got a modem which has got an IP address of 203.20. Whatever, right? That IP address. What I'm saying is when I connect my computer to the modem, okay, the computer doesn't have a public IP address. The modem has a public IP address. Every modem which is connected to an ISP, what the ISP gives you effectively is a connectivity with a public IP address. Okay, now you've got a device called as a Wi-Fi router. It's actually a router. Internally, it has got a Wi-Fi switch as well. What does it do? It internally gives you multiple IP address for the private devices in the network, and it lets you connect to the ISP through a public IP address of this sort. Is it confusing for you guys?
Yeah.
It could be. Doesn't matter if it is confusing. I'll tell you. I'm just giving an example of what happens in a daily world at your home computer. Can I ask you, if whoever who is working on a laptop, can you issue the command, this one, ipconfig, from your command prompt? Can you issue that command? Do you know how to do that? Press the start button.
The command prompt.
CMD, it goes the command prompt. Just do a ipconfig. Can each of you, whoever has done that command, has got an output? You will get an output against IPv4 address. Do you see that? Can you try that while we talk?
Sir, can you tell what you said again, because it was lagging for me?
Okay, so go to your command prompt. Do you know how to go to a command prompt?
Yes, sir.
Okay, go to a command prompt. I'll tell you step by step what you need to do. Have you gone there?
I know, so I'm taking it.
Yeah, okay. So once you are there, just let me know.
So like for the command prompt, we should type ipconfig.
Yeah, it's there on the screen. Just follow that command, this one.
So they're saying ipconfig is not recognized as an internal or external command.
What operating system are you working on? Are you on a Windows?
Yeah, Microsoft Windows.
Did you put a space in between IP and config?
No, sir, I think I didn't.
No, you should not. It's one word, IP config. Okay, let me show my screen. Can you see my screen now?
Yes, sir.
Okay. Did you see the command? I'll clear the screen. ipconfig. It should give you this output.
Yes, sir. Now it's giving.
Okay. All right. So Abhiram got it. Ritesh got it. Someone else? Anyone else has that? Okay. So let me go back to sharing. I hope you guys are able to. Okay. So in your IP config output, you will also see something called as do you see that?
So there is default gateway.
Correct. Yeah, default gateway. Do you see that?
Yes, sir.
Do you, what IP address? Who was that? That was Abhiram, was it?
So
Ritesh. Ritesh, what is the IP address you are getting there in against that?
So like there is some FE80 and then below that there is 192.168.100.1.
So you know what? That IP address is the IP address of your modem. Okay.
Okay, sir.
If you want to go to the browser and then type http : this is just for Ritesh, okay? Basically, if you go with that IP address into your browser, okay, you should be able to get the screen of the modem. And if you go into the user ID password and hit enter into the modem, you will get the configuration details of your modem. And in that, you can see that your modem has got this IP address in Ritesh's case, and there will be a public IP address as well. I don't know, the public IP address could range anywhere from 10.0.0.0 to anywhere from that to 255. So there could be some of the ranges will not be available, but most of any of these IP address can be assigned to it other than 192. So you can
the results right now.
sorry, say it again.
I got it, but it asked for the username and password.
Yeah, you might not know the user ID password. If you know, you can go in. But what I am trying to say is that your modem at your house has got two legs. One leg is your private leg. The other leg is your public leg. So the 192.168.100.1 that you saw is the leg on the private side. The other IP address, in my case, it was 203. You guys saw it, right? Whatever that IP address was. Did you see that?
Yes, sir.
Remember that? That is the public leg of my modem, which is connected to the ISP. Okay. So what happens is when someone hits google.com, remember what I said in the OSI layer? In the OSI layer, this is very important that you understand this. How many layers in the OSI model?
So 7.
Okay, can you tell me which are those layers?
So physical,
Detail.
data link,
Good.
network,
Application.
Not yet.
Transport.
Correct. Please do not throw. Remember the
Session
code?
layer.
No. Please do not throw.
Application.
No.
presently.
Pizza. What is the next one?
Service.
Session layer.
Session layer.
Session layer, sorry.
What is the next layer?
Application layer.
Application.
Application layer, correct. So I'll take an example of Ritesh, right? Ritesh is trying to hit www.google.com on his computer. Okay. What happens when Ritesh types www.google.com? He opens the Internet Explorer, which is this one, application layer. The data flows from application layer. It records some information of the session. It records what protocol is he using. It records what is the source IP address and destination source IP address. It records what is the destination IP address. It records what is the MAC address, and it goes out of the physical packet. So, correct? You remember all that?
Yes, sir.
Yes.
Okay,
Sir.
so you have a huge packet which is going out with a lot of information about your data. On top of it, what time the data was written, what network you are starting from, what is the protocol that is getting used, HTTP here, your time, session time, all of that information goes out of the physical layer. From the physical layer of your computer, where does it go straight into? Because you are at home, where does it go straight into? So this is the data packet. This person is traveling to Google. Okay. With all the data that you have put in, you're traveling to Google. What is the next step? This is out of your physical layer of your computer. What is the next step? Where does it go to? Ritesh, can you answer that?
Sir, I'm not sure.
So when you have your computer, laptop connected to internet, we just imagine that picture. You've got your computer, you've got your modem, ISP, Google. So the physical layer of your computer, you have written www.google.com. Next step is what? It is gone out of the physical layer, which means it is left your computer. Where is the next hop?
Sir, to the Google server.
No, there's multiple things in between. You have your switch Wi-Fi router, right?
Yes, sir.
Yeah, so it goes to your Wi-Fi router. Because, and this is why I asked you to check what is the default gateway in your computer. The fact that you have a default gateway and there is an IP address there, when the data packet goes out of the physical layer, the first hop that it reaches after the physical layer of your computer is your default gateway. In your case, the default gateway IP address was 192.168.100.1, correct?
Yes, sir.
So it goes to that device first, because you are giving a path for the data packet to go. You are telling in the configuration of your computer, when it is connected to internet, you are making your computer realize that the external person that you have to send the packet to is your modem or Wi-Fi router, whatever it is. Correct?
Sir, it is received also by the modem.
Yeah, don't worry about it. We are only going from, so I'll reach there. We will reach there in a minute. Okay, so first is you are sending the data out, then reaches Google, the return packet comes in. I'll talk about it in a bit. But
Okay.
as a first step, the first hop after it leaves your computer is what? Is your default gateway. Okay, that is why it is called default gateway. Why is that called default? By default is what happens, the next one. What is the Malayalam for by default? I don't know. Default means the obvious next step. Make sense?
Yes.
So in your computer, in the operating system of your computer, when the internet connectivity gets established, your network interface card will get A, IP address, B, it will also get the details of what is your next hop. Okay? And the next hop is your default gateway. And this is the principle applied for every single network device in the world. When a network device gets connected to internet, the first step is when it is connected, you will get an IP address. The second step is along with that IP address, you will also get what is his next stop or next hop. Okay. So this is like you getting a plan, okay, a route to where you want to go. The first step, if you want to go out, is get out of your house. Correct? You have to open the door and go out. The default gateway to go out of your house is your exit door. Correct?
Yes.
Okay. If you are a individual house where you have a front door and a back door, you could go either way because you've got two gateways. But if you want to go and, by default, or I don't know what is the other word, by the obvious next step that if you want to get out to the road could be your front door. And you're in your house, you establish saying that whoever wants to go outside, go through the front door. Because we are human, we have intelligence, we can check which way we have to go first. But in the case of a laptop or a computer, it is a dumb device, it doesn't know which way to go. So you have to tell him, okay, the next step obviously is going to be your default gateway or your front door, whatever it is, right? Does it make sense to you guys? So if you look at your internet connection, not by checking whether it is connected to Google or not, by testing the browser, your better way, the better way to check whether the computer is connected to internet is go to your command prompt, check IP config, check if you have got an IP address, check if you have got a default gateway assigned. If you have these two, what does it mean? It means that the computer has a network connectivity. It doesn't always mean that the network has an internet connectivity, but it has a network connectivity because it at least know where to go. Correct? Now the default gateway is modem or router. When the packet reaches the modem or the router, the modem has got another leg outside, which is your public IP address. The modem or router, the router actually reads the packet. When it reads the packet, it understands, oh, this guy wants to go to google.com. Now, I can't see google.com in my device connected directly. So a modem will have a default gateway. Okay, your computer has a default gateway. Your modem also has a default gateway. The modem then decides, okay, I am sending all my default gateway is the public IP address or the interface where the public IP address is configured. It just pushes the packet to the public IP address world where that leg is. Does it make sense to you?
Sir, like I don't understand, sir. Like the default gateway of the computer and the public IP address of the modem is the same, or is it different?
It is different because it is two different devices. Your computer is a different device as to modem, right? The modem is a totally different device. For your computer, the default gateway is the modem. For the modem, your default gateway is the modem's default gateway is a different one. It could be the public interface of the modem.
Okay, sir.
That, so it is like, you know, you, if you pretend that you are living in a sort of a complex where you've got multiple houses. Okay, you want to get out to hit the road. So you've got two gates to go. One is your own gate, which is your front door. You get out of the front door, and then obviously you know you have to go out. What is the next door that you have to hit? The door of the building. So this is a scenario where you are living in a unit or a flat, in a building, and you have to go out of your room to the and you want to hit the road. What you do, obviously you get out of the house first, or your unit first. Once you get out of the unit, the next is the building door. Assuming you have got multiple buildings in a community and you have got a big gate out of the building, okay, what will happen? You've got another exit door out of the complex. So every single device connected to a network with a device like a router or a switch will always have an IP address and a default gateway. It is about the network engineer to design how the connectivity goes from your own personal computer out to the world through what path. Okay.
Okay, sir.
If you don't understand this, I am happy to explain it again, but it is important that you understand this. So any computer, let me rephrase this, any computer or any device which is connected to internet has got two primary things which it needs to have. One is the IP address, which will give him a distinct name or identity. The second one is his exit door, which is your default gateway. Once you have a default gateway, the packet moves from that computer to the default gateway. In your case, in a house, the usual default gateway is your Wi-Fi router or modem. For your Wi-Fi router or modem, the obvious default gateway is going to be the public interface of the modem, which is connected to the ISP. Now, assuming that it went out of your modem, it went all the way to the ISP. ISP has his own network. So depending on what device this packet goes into, it goes into that device, and that device again will have what? So every device has an IP address. Every device has what?
A default gateway.
A default gateway. So this is the fundamental in which the data packet transfers from one device to another device to another device. Make sense?
Yes, sir.
So the planning, a network engineer's responsibility is to ensure that the optimal path is being used for any data packet transfer. What is an optimal path? An optimal path is the shortest path. Why the shortest path? Otherwise, your network bandwidth or network response time will be really, really slow. Okay?
So, but won't this method create a lot of traffic?
It will. It will. It has to. So, to avoid congestion, remember we spoke about physical, network hub, a network switch, where in which packets are getting broadcasted. There are devices which are actually smart to identify from which location to go to which location. Remember that?
Yes, sir.
So, a very good question that you asked, Ritesh, and which is to my next topic was, what type of device should be used in each of these scenarios to avoid congestion. So the design person, whoever is designing the network, will design it in such a way that there is minimum congestion. It doesn't mean that there won't be any congestion, right? The optimal path will decide for every single data packet to move effectively, and the better design or better network configuration of devices, the type of devices that are being used will determine whether the network is quicker or slower. Assuming one of you said last time you are in Oman and you use Omantel as a service provider. Assuming a scenario where in which you have a good Jassy router, which is the best in class that you have purchased. Your parents have purchased the best router which is possible, which means that it can process multiple data packets so effectively and quickly. Assuming that the internet service provider has got the worst network packet transfer device in the world. Say, for example, I mean, just it will never happen, but just for example, I say he has put a hub to get the router, get the packet inside. Whatever, however speedy device that you have at home, it doesn't matter. Your internet service provider using an old device or an underperforming device will determine how much speed will you get in browsing.
Okay, sir.
There are other factors also which determines the speed of the browsing. I don't know if you have heard something called as broadband, and there are something called as fiber channel devices and all these things. Have you heard about this? ADSL connectivity, a DSL connectivity, all of these kind of things.
Yes.
What does this mean? What does it mean by, oh, I've got a DSL connectivity, oh, I've got a dial-up modem, oh, I've got a fiber channel card connected to my my home network? What does all this mean? How does it matter when we have different types of devices available? How does it matter which one should be used?
Through the high speed.
It is the performance. It's the performance gain that you get by optimizing every single element of your network. So if you have a Wi-Fi enabled device at home and the Wi-Fi has got a couple of different speeds, the switching speed is different. That actually matters how the performance of your home network works. Now, assuming that you've got a copper cable, which is not really effective, but you then your performance of your browsing will be impacted. Assuming you have got a fiber cable has got a much better efficiency in terms of communicating data from a packet from one device to another. You might learn why in your physics class as to how an optical cable will make the efficiency of or the the data loss less. They've got something called as interference. Remember that? I don't know if you guys have gone through it yet, but you will get to it. So there are different devices which are connected at different stages in your computer networks, which enables you transfer data in an effective way. The service provider network will also identify what is the best fit for a particular data transfer. So there are cases where you might have to watch YouTube. There are certain cases where you have to watch only, you have to send email and, receive email. In both the cases, the network requirement is totally different. But from an ISP perspective, he can't decide which of his customer is going to use a text protocol versus a streaming protocol like YouTube. Correct? So the ISP's job is to ensure that his customer gets the best efficiency, and he will design his network in such a way that the end customer gets the best throughput. And the best throughput could be in multiple services. The services could be a DSL, the services could be a ADSL, there could be a broadband, then there could be a fiber broadband, different technologies available out there. The selection of which technology is required to do what entirely depends on what you are going to do with it. Make sense?
Yes, sir.
So I wanted to talk about IP addressing public and private. I wanted to talk about routing and switching. I wanted to talk about NAT. We actually started NAT. Okay, I will detail that in the next session. But I think what is important is you understand all about this IP addressing, the default gateway. That will give you a bit of basis as to what all things are happening. And please bear in mind, if you have to understand this completely, you have to have that picture of a computer connecting to a switch, which is your Wi-Fi router, and then to a modem, which is actually inside the same device, and then connecting to an ISP, and then ISP forwarding the request out to the modem. To the respective Google or Facebook or whatever service that it wants to connect to. So it is very important that you have that picture always, because whatever I'm going to go talk about in the future will be entirely based on that connectivity. So every single element of that entire chain needs to be in your mind registered. Okay, no, I forgot to ask. Did you find out what is happening from a public IP address to a private IP address and vice versa, which was the kind of question that I asked in the last session? Did you find out how it was?
So like you asked that if there are two people in the same house and they have the same IP address, how can they?
No, they will not have the same IP address.
No, like they are using the same Wi-Fi.
Yeah. Yes.
But then they are using, like, they are, one person is in a meeting, another is like watching a video on YouTube. How are they able to do it? So
Correct.
I'm not sure. Like there are many methods I found out. So first I thought what was like this modem will has a switch which can read the MAC address and then send the signals to the ISP, and the ISP can differentiate. But I guess it was wrong.
No, well, look, it's a very good assumption. Let me tell you this, right? It's a very good assumption, and it is a very realistic way of looking at it, right? What you assumed is perfect. What you assumed is perfect, but it is not just that the Wi-Fi router reads the MAC address and then forwards it to the ISP. There are two more steps which happens in the modem before it hits the ISP, which is why I was trying to shift my focus from a data link layer of OSI reference model to the next layer, which is the network layer. So when I explain the network layer and its functionalities, I could have gone down the path of talking about routing and switching first, but then what I thought was, if you don't understand in reality what is happening, you might not be able to relate to it. That is why I am taking the example of someone sending the request from his browser google.com, what all steps happen, and then I will align you or bring you back into the OSI layer and then relate it. So in a nutshell, right, what Ritesh, you were absolutely right in assuming that when you or your parents use different devices at home, the Wi-Fi router definitely does the data link layer reading, and then based on the MAC address, it will determine which device is which. But the next step to it is something called as routing, which is the next step happening in the network connectivity diagram. Okay, I will explain you for sure in the next class.
Like sir, even I had one more thing, like we might have heard of 5G or something like that.
Yes.
And so this device connects to different signals from the modem. So like the modem manipulates the signals and sends it to different devices, so they connect to a separate signal and then they can network. Like I thought about that also, because I even
well, that's not how you have to think. Okay, let me tell you this, right? A 5G, 4G, 3G and all these things from a modem perspective or a mobile device perspective, it is about the efficiency in bandwidth that you get. It is not about network switching and all these things. It is about how much speed you get from the modem outwards. So the technology that you are selecting here is your switching and routing network packet plus the traversing of the network packet from one point to another, which could be through a microwave, which could be through a infrared or Bluetooth or a cable or optical cable. So those are called the medium of transfer.
Yes.
There is your device connecting to your router, and from the router, when it goes outside, you could take airway, you could take railway, you could take transport, bus. There are multiple ways of transfer, right?
Yes.
Likewise, in the world of computing also, you've got multiple ways of transfer. So you select a 5G or 3G or 4G or 5G or ADSL or fiber optic broadband, whatever it is, that's your medium of transfer. That is through which the data goes. And there are different technologies for that. In the networking engineering section that we are discussing about, we are not focusing on what is the route you take or what is the medium that you take to get your data across. We are only talking about how or what all devices it goes through and what are the mechanisms in which it goes through. Make sense?
Yes, sir. Like, sir, I thought about this because I've heard that like this signal is faster than that, and when you take it, like when you use more devices, the
Yep.
signal strength will slow down for one device. So I thought that maybe these devices are also connecting through the bandwidth of this by
Yep.
giving separate signals.
Correct.
So,
Correct. All of that is right. All of that is correct. So it is again, if you want to go from for a distance of 100 kilometers from where your house is to another house, it is the route that you take is what we are discussing about. Whether you take the route, how you travel, whether you are traveling by bike, where you're walking, or you're taking a public transport or a private transport, that is a different discussion altogether. So there could be a reason where in which what I'm trying to say is you could have, depending on, depending on your ability, you could actually get airlifted from your house to the other house. You can say, okay, get me a helicopter. I'll go to that place. But end of the day, you are actually going. And how you are going, you are actually going out of your house. How you are going out of your house or how you are going to the destination is not what we are discussing about. How you are going to the destination, in this case, airlifting, is probably the 5G network, right? Because that's the most, quickest network that is available today in the case of mobile networks.
okay, sir.
It could be that, you're having a fiber broadband at home, which could give you hundreds or 200s of gigabits per second as a speed. Because those are all your medium of transfer. So don't mix yourself from medium of transfer to your method of transfer. What we are talking about is the method of transfer, not the medium of transfer. Make sense?
Yes, sir.
Yeah. Okay. We'll talk about it in detail next class. I hope you have a good, next week, 1 week.